Hello, and welcome back to Shiksha Costa. Today we're going to summarize our unit on solving financial problems that involve exponential functions. So throughout this unit, you compared the simple and compound interest for a given principal. You solved problems that involve calculation of the amount and the principal of a investment that's growing with compound interest. You determined that compound interest is an example of exponential growth. You solved problems that involve the calculation of the number of compounding periods and the interest rate per compounding period using a TVM solver. Hopefully, by now, you're able to explain the meaning of the term annuity, and you've determined the effects of changing the conditions of ordinary simple annuities. And finally, you solved problems using technology that involve the amount, the present value, and the regular payment of an ordinary simple annuity. If you've done all of that, then hopefully you're able to demonstrate that you understand compound interest and annuities, and you're able to solve related problems. We started off by learning about interest. Interest is a fee that is charged for borrowing money. It can also be used to mean investment profit. Interest is usually calculated by taking the principal, which is the original amount borrowed or invested, and multiplying it by the interest rate for each year of the term. Simple interest is calculated on just the principal. The formula is A equals P plus PRT. A is the amount, P is the principal or the original amount invested, A is the amount at the end of the term, R is the interest rate annually, and T is the term, which we always represent in years. Investments and debts, they grow in value as time passes. So making a timeline is always a good idea. If you increase the principal, if you increase the interest rate, or if you increase the term, that will increase the total amount of interest that is paid. When you add the interest of a loan or investment to the principal to create a new higher principal, this is called compounding. And that makes a principal grow much faster than just simple interest does. If you are given an annual interest rate in a term, and then you're given a compounding frequency, which could be daily or weekly or monthly or quarterly, this will tell you the number of periods in a year. And we use the variable f for frequency to describe that. You can use that to calculate the interest rate per period by taking the annual interest rate and dividing it by the number of periods or the frequency. And you can also use that to calculate the number of periods in the entire term, where you take the number of years and multiply it by the number of periods per year. Here are some very often used frequencies. And this is what they mean. And this is how many periods there are in a year. Obviously, daily means every day, and there are 365 periods, which are 1 day long in 1 year. Now that you have all of that information, you have the interest rate per period and the number of periods, you can calculate the total amount of a loan that's growing with compound interest using this formula. And if you want to find out just how much interest you've paid, you can take the future value and subtract the amount you originally invested, and that'll tell you the total interest. When you're calculating the rate and term for simple interest growth, that's pretty simple. But if you're doing that for compound interest, that's much harder. So we learned how to use a TVM solver to find the interest rate per period and the number of periods. All you do is you input all the values that you know. When you're putting the present value, put it in as a negative number. And then just click on the one button for the one that you don't know. Make sure the payments are set to 0. We learn about that later in annuities. And then you just click on the value that you don't know, and the TVM solver will tell you its value right away. An annuity is what we learn next. This is a financial product that involves multiple regular payments. And the future value is the total future value of all the regular payments. So notice over here, this is this is maybe a timeline. This is my first investment at $100, and it grows until it reaches $107.23. And that's after 12, let's say, months. My second investment, I invested 1 month later. So notice it has less, it only has 11 months to grow. And that's why it doesn't grow to as high. This is my third investment, my fourth, my fifth, and so on. And the annuity is the sum of all of these. They're all separate investments. And the future value of the annuity is the total value of all of these. And this value, you can either do this separately and add them all up, but that might take a really, really long time. Instead, you can use a TVM solver, or you can even use a formula. This is the formula for the future value of an annuity, where R is the amount of each regular payment. So in this case, it would be 100. I is the interest rate per period, N is the number of periods. If you know that you want to reach a certain future value and you want to calculate, well, how big do my payments need to be to get there? All you have to do is isolate R. So just divide both sides by this expression. FV divided by this will equal R. The most useful tool or the most useful way that we use annuities is retirement savings. So usually to save for your retirement, you'll save a steady amount every month or every 6 months or whatever have you, but in a regular manner. And then by the time you retire, hopefully you have a ton of money waiting for you, and you can calculate just how much you will get if you assume an interest rate and you are making steady, regular payments. Now there are three different variables here to calculate future value. There is the amount of each payment, the interest rate, and the number of periods. And over here we saw that when we change those three and increase them or decrease them, this is what happens to the total amount of interest, which is in red. So if we increase the interest rate, the total interest does go up, and it goes up, at an increasing manner. When we increase the term, the total interest goes up by a huge amount, even more than this. Even though our payments increased for sure because we were doing it for longer, the total interest went up way more. And when we increased the payment size, the interest also increased, but it increased proportionally to our payment size. The last concept we learned is present value of annuities. The present value of an annuity is the amount you need at the start of the term to make withdrawals, not deposits, withdrawals until the fund runs out. And it can be calculated with a TVM solver or with a formula. This is the formula. If you're using a TVM solver, the future value must be 0. And the withdrawals must be a negative number. The payments must be a negative number because you're making withdrawals. You're taking money out. And to calculate the size of the withdrawal, you can use the formula as well. Just isolate R, so divide by this expression right here. And that'll tell you the amount of withdrawals that are possible if you know the amount of money that is in your account to start with. The most useful way we use present value for annuities is to find out how much money you need at the start of retirement before you can comfortably retire and pay yourself an income. For example, let's say you started with $56,275.39. That's your present value. After 1 month, it'll grow with some interest, and then you'll make a withdrawal. And it'll grow again, and you'll make a withdrawal. And notice, because you didn't withdraw it all at once, the amount that is remaining, this 51,000, was still able to grow. So you made some interest off of that. And then you only withdraw maybe how much you need for that month. And then you can keep going from there. And every month you'd make a withdrawal, and then it grows. Whatever's remaining grows a little bit. You make a withdrawal, and then it grows a little bit. And that keeps going on and on and on. And in this case, we've calculated we need it for exactly 12 months. And the longer we make withdrawals, the amount of interest that is growing is less. Until finally, our 11th withdrawal leaves us with exactly $4,950.50. When it grows with interest, it gets us $5,000, and that is our last withdrawal, which takes us to 0. So that's present value of annuities in a diagram. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.